Hello, my dear friends. Today we will discuss basic satellite communication part 4 regarding frequency and radio wave propagation. See, for wireless or radio or the satellite communication, frequency is used at carrier which carry the message, data, video and the TV and the image from one location to the other location. In the real world, the communication or the carriers was used to transport the goods or the people. We have used many means like man, animal, and in mechanical ways the like truck, ship, aeroplane. All these are used and all those are having in different capacity. Similarly, if we talk in a frequency from lower frequency to higher frequency, the carrier is used and will have different capacity. For our voice communication, the man, we talk and we listen. We talk by mouth and we listen by ear. And we can think that the ear and mouth are 90-degree apart. And nothing is coupling from ear to mouth. If it will couples, then we cannot do it. We cannot listen or we can talk. Therefore, nature has provided this. If we will compare to the wireless communication, antenna plays a major role for coupling the electromagnetic waves from the device or the equipment towards the open space. This antenna plays a major role in this communication era. And now we can see that antenna is everywhere and with everybody. Previously, big reflector and the antenna array were used to transmit the communication. But when year passed, the technology advanced, then it has reached to the small mobile set. And now you can see the mobile life is like that. Every corner, every family, everybody even will have more than one telephone set. And this antenna plays the major role, was invented by a German scientist Heinrich Haas in 1886. After 20 years, during 1901, scientist Marconi has developed the radio and he was able to transmit the message from uh, above the ocean. And that time he has suffered a lot from the cable factory because the transmission of signals was routed through wires, cables, waveguides before the radio wave invention. Nowadays, we are using all those methods in associate with this wireless system because from antenna these things wires, waveguide and cables are connected to the user's point. As on today, the optical fiber cable are most advanced, will have very less interference and in a low loss. These cables are used everywhere along with these wires and cable. Today we will discuss the frequency and the radio wave propagation with briefly. Our electromagnetic waves, our electromagnetic waves travels as per the light velocity, which is c, is equal to 3 into 10 power 8 meter per second, 3 lakhs kilometer per second. And when the frequency oscillated from 0 to 360 degree or crest to crest, it will be termed as lambda, and that will be in meter. Lambda is equal to c by f. C is equal to light velocity, f is frequency in hertz, or c, which is constant, the light velocity is equal to frequency and lambda. If lambda is less, frequency will be more, and vice versa. If frequency is less, lambda will be more. For 1 kilohertz frequency, lambda will be 300 kilometer. For 1 megahertz, which is 1000 kilohertz, will be 300 meter. For 1 gigahertz, which will be 1000 megahertz, will be 0.3 meter. For 30 gigahertz, it will be 10 mm. For 300 gigahertz, it will be 1 mm. Broadly, the electromagnetic spectrum is divided in 7 parts. First is radio waves, then microwaves up to gigahertz, infrared IR terahertz, which will be 10th power 12, and gigahertz will be 10th power 9, visual band petahertz 10th power 15, ultraviolet UV petahertz, X-ray and gamma rays. In infrared, the light wave communication, which will be carried by optical fiber cable, taken place, and now it is mostly used the optical fiber cable everywhere. For wireless, microwave or space communication, the frequency is used from 30 Hz to 300 GHz range. At present, because this was started in beginning of 19th century up to today, last 100 years, many things happened, and now we're arrived with latest communication used by high frequency will be some 30 gigahertz or 40 gigahertz or 50 gigahertz. These bands again for radio wave propagation, that radio waves or microwaves are further divided as UHF, L band, S band, C band, X band, Q band, K band, finally Q and V band. In all the bands, again frequency are subdivided by uplink and the downlink. And in the beginning, the communication takes place below 30 megahertz, which is called ground wave, which are direct ground reflection and surface wave. And these are used for our AM radio, amateur radio, and radio navigation, land mobile services. Then next, less than 300 megahertz ionospheric propagation was taken place. These are for commercial FM, VHF, and TV band. These are taken place height of 15 km to 400 km distance from the surface of the earth, and these are interacted with three layers, D, E, and F layer, and all these layers will have their own phenomena. Then in C, if we see 3 megahertz to 3 gigahertz communication, which will be tropospheric or forward scattering wave, started between 10 km to 20 km height from the surface of the earth, and this will be used for long distance communication, and it is rare, and it will be used when there is no other means are available. Finally, the direct or line of sight wave, direct terrestrial radio communication and broadcasting, and the space wave or satellite communication, all are having a frequency sharing. This line of sight communication you can see all over the earth. Direct to direct points are transmission in taken place, and this will take a lot of data, message, and video, etc. But to cover all the earth area, this type of communication are very difficult to cover up fully compared to the space wave or the use of satellites. Therefore, here whatever the frequency are used, mostly it will be used by these. Therefore, a sharing is necessary, and it will be shared, which will be organized by International Telecommunication Union and Frequency Coordination Center. In lowest frequency communication like ground wave, ionospheric, or tropospheric, there are so many propagation mechanisms or propagation phenomena taken place like absorption, scattering, refraction, diffraction, multipath, scintillation, dispersion. Finally, in high frequency 10 gigahertz and above, rain attenuation and gaseous attenuation taken place. These are the anti-phenomenon which will be faced by the electromagnetic waves during communication due to the nature of the atmosphere and the nature of the site where it is situated. And in radio wave propagation, it depends on again the frequency and the elevation angle of the transfer receive station. And so many mechanisms or the methods are adopted to come out from this, because due to this propagation phenomena, the frequency, bandwidth, their amplitude, polarization, and the angles of arrival will be get disturbed. And for rain and gaseous attenuation above 10 gigahertz to higher frequency, the attenuation of the signal and the polarization will be affected, and the attenuation, rain attenuation will be affected as the frequency will be compared to a rain attenuation will take place and varies according to the frequency square. Say 10 gigahertz, whatever attenuation will take place. 20 gigahertz, 4 time attenuation will take place. And for that, different methods are employed to avoid and give a sufficient margin or the availability of the communication. In OFC, optical fiber communications, around 1550 nanometer wavelength frequency are used, and those are again two types divided, two parts, single mode and multi-mode thing. In satellite communication, whatever frequency we use, it will have their own bandwidth. Higher frequency will be higher bandwidth, and required technical advancement for building the devices, and now those frequencies are again subdivided for use of commercial and military purpose. And for rain to counterpart of the rain attenuation, some diversity way and the power control mechanism are adapted for microwave equipments and microwave transmission path through the satellite. And this line of sight, though The power constant is not much. This will be used for with high dynamic range to avoid this local made attenuation. Okay, today as a brief description we have seen the frequency and radio wave propagation. For next part we will see or we will study some of the things. Thank you very much.